O Grupo Energy Telecom, através de suas 4 empresas, atua em todo o Brasil, integrando os principais serviços e soluções quando pensamos em tecnologia. Projetos de Public Cloud, comunicação unificada, Big Data, infraestrutura, Data Center, Client License, Cybersecurity e educação. Você pode contar com o Grupo Energy Telecom. Sempre a melhor solução.
Nós protegemos a tecnologia para você explorar novas realidades. Fazer o que quiser, quando quiser. Fazer amigos virtuais. Estar perto, mesmo estando longe. E conquistar novas fronteiras. Garantimos sua segurança digital para um futuro melhor. Kaspersky. Bring on the future.
Vale do Paraíba, uma região única com múltiplas vocações. A nossa é a tecnologia, é a inovação. Nós somos a NIP-BR. Trabalhamos para integrar, conectar, expandir, informar, entreter. A NIP-BR é solução corporativa, é internet, TV por assinatura, é telefonia digital. Os melhores serviços com o melhor custo-benefício. NIP-BR, sua melhor opção em internet, telefonia e TV por assinatura.
Você é daqueles que acham que ser moderno é ter um aplicativo para cuidar do seu dinheiro? É também. Agora, moderno mesmo é fazer parte de um grupo de pessoas que cooperam e crescem juntas.
Tem gente que acha que um bom atendimento é ter um gerente pronto para te ajudar. Nada mal, né? Mas pra gente ter voz e participar das decisões relacionadas ao nosso dinheiro.
Tem gente que acha que somos um banco. Somos muito mais. Somos feitos de valores.
Our infrastructure and natural resources can't keep up with growing demands. We need to be smarter. We need to care more. It's time to create smart infrastructure. We can because we connect energy systems, buildings, and industries to adapt and evolve the way we live and work for the good of the planet and the people. Creating environments that care. Smart infrastructure from Siemens.
A maior rede de pesquisas do mundo, com 5,5 bilhões de acessos por dia. Uma rede social avaliada em 70,7 milhões. Sabe qual a semelhança entre essas empresas? O investimento em softwares e algoritmos inteligentes. Tinova e SPS.
Na era da transformação digital, a Tria Software é o seu parceiro ideal. Trabalhamos com a aplicação de solução em software padronizada ou sob medida para melhorar o desempenho dos processos de sua empresa. Tria Software.
Nós abrimos oficialmente o 4º Fórum da Indústria Espacial Brasileira e agora, 12:03, já vamos para o primeiro painel do dia. A gente vai mostrar para você como o setor espacial pode ajudar na agricultura, pode trazer soluções para esse negócio. Lembrando que essa palestra tem duração de 1 hora, esse painel, e ela será feita em inglês. Se você quiser receber a tradução simultânea, basta abrir a sua plataforma, no lado superior direito, você encontra o ícone de um globo, um planeta Terra. Basta clicar ali e você recebe então a tradução simultânea dessa palestra. Vamos conversar agora então com João de Mendonça, da Embrapa. Tudo bem? Ele vai ser o moderador dessa palestra. Uma ótima tarde, já estamos tarde, uma boa palestra.
Boa tarde, tudo bem. Let me speak in English. Good afternoon. First of all, I'd like to thank the Brazilian Space Agency and the organizing committee for the invitation in this highlight on agriculture. We are honored to participate in this forum. My name is João de Mendonça Naime. I am a researcher at Embrapa, the Brazilian Agricultural Research Corporation, and I'm an electronic engineer specialized in automation systems dedicated to soil physics analysis. Since 2015, I'm the director of Embrapa Instrumentation, one of the 43 research centers of Embrapa, which is located in São Carlos, state of São Paulo. Embrapa Instrumentation coordinates 2 national laboratories, automation and precision agriculture, and nanotechnology applied to agriculture. So, let's describe the theme of this section. Agriculture has drastically changed in the last years, thanks in part to the space technology. New products, services, and technologies such as GPS and satellite remote sensing have been used to increase field productivity. To discuss this subject, we have here today Christian Jardim Vitorino from TecTerra, Yasunori Yamasaki from Axial Space, João Paulo Campos from Visiona, and Leonardo Antolini from Kinetic Craftsman Group. Let's start the presentations with Mr. Christian and Mr. Yasunori. You both have 15 minutes. Please, the floor is yours. Thank you.
Thank you very much, Dr. João. It's a pleasure to presentation in this Congress. Thanks for the invitation. I am a partner at TecTerra. TecTerra Geotechnologies is a company that offers remote sensing services, mainly in the sector of agribusiness. And I introduce here Yasunori Yamazaki, CBO of Exospace, a Japanese startup that has developed Earth observation, microsatellites with a high image acquisition capacity, and that will be a very important contribution to the agribusiness sector as it has unique characteristics in terms of spectral resolution or spatial resolution too. Yasunori, thank you for your presence and availability. Remembering that in Japan, already on the 21st, feel free to start your presentation. TecTerra is a partner of Exospace here in Brazil. Yasu, thank you very much. Feel free to start your presentation.
Thank you, Christian, and thank you, Doctor. It's a great pleasure to be part of this panel. My name is Yasu. I'm the Chief Business Officer of Exospace, and I'm logging in from Tokyo, Japan, at the moment. So I'm thankful for the technology that's connecting us all today. So, Exospace, I'm just checking my clicker. So Houston, okay, we have, okay, so it's a little bit of a delay since I'm sitting on the other side of the planet. So Axospace, we are based in Tokyo. This is our beautiful office in the middle of Tokyo. And, okay. Yes, so we are powered by more than 80 people from more than 20 different countries. We also have someone from Brazil, so I'm very happy to say that maybe he's joining us tonight, watching this because he was excited. So essentially, we are in the business of satellite manufacturing. So we design, build, and operate a microsatellite. I'm just experiencing a little delay here in the presentation. Okay, great. So this image is the real image of our real satellite sitting in our office, ready to be launched very soon. And using these satellites, we are capturing images around the world for various purposes, including monitoring of the agricultural crops. And in order to reduce the cost for people to use satellite imagery data, we have decided to create our own infrastructure called AxoGlobe, comprised of multiple microsatellites capturing images at 2.5 meter resolution with blue, green, red, reddish band, and near infrared. So with the resolution and the spectral bands, we are hoping to contribute to the agricultural sectors around the world, including Brazil. So the AxoGlobe is in operation and has been capturing images, including Brazil, and partnering with Tecterra, Christian, we're hoping to provide services in Brazil. So our images has various ways of capturing the crops, and of course we are able to capture in true color imagery, which essentially means the normal images, just like the pictures. Okay, yes, just like this. So this is a real image, real satellite image from our satellite, capturing one of the crop fields. And by capturing in different periods, we can see the progress of the crops. So you can see the green is increasing here as we continue to capture the images. Apologies, looks like there's a delay in the clicking, but we'll just continue to move on. Let's see. And of course, because we carry the spectral bands, which allows the NDVI analysis, we are able to give a more dynamic insights regarding crops. So just waiting for this. Yes. So the previous slides, we showed you the images at true color, but this one allows you to see in the NDVI images which essentially means that the color is divided into different colors based on the growth of the crops. So here, how you see this is the more red it is, means the crop is in the growth stage. So as you can see, using the NDVI, you can see the growth of the crops as we continue to monitor the same area. Now, what we can also do, because we have a higher resolutions, higher spatial resolution than some of the freely available satellite imagery data, we are able to do what we call parcel delineation, meaning that we can divide each fields into specific unique sections. So here we're showing that we are dividing into different fields so that we can actually provide analysis based on each individual fields. And if we are able to divide into these individual fields, what we can do is the analysis based on these individual fields, which is what we call the zonal statistic visualization. So what this means is that based on the parcel delineation that we have conducted, we are able to analyze the growth stage of the crops based on each of the fields. So for example, maybe sometimes the owner of these fields may be different. You can actually give the analysis for each of the different owners of these fields. And this is possible because you are able to get access to higher resolution than the freely available data that is available. So this is one of the reasons that you may want to consider accessing the commercial satellite imagery data like we are providing, because you can actually divide into different fields. Now, one of the highlights for our satellite is that we carry a special band called red edge band, which allows us to do not only NDVI, but NDRE analysis, which is only possible if you carry the red edge band. So this actually is a real image from actually Brazil. So this is somewhere in Brasilia that we captured and prepared for tonight. And again, we are able to do the parcel delineation, which allows us to divide into different fields. And the left chart just shows the different crop state, the growth stage of the different crops. So that's it from me for tonight, Christian. I'd like to hand it over to you. That was Axospace. Thanks so much.
Thank you very much, Yazoo. I want to talk about more than 4 satellites will be launched to increase the image acquisition capacity. It's very important to point out we now offer through this technology, through these Axospace technologies, many possibilities for differentiated analysis for the agribusiness sector, with a high capacity for image acquisition, for monitoring and products. So I believe that this technology can greatly enrich the agribusiness sector here in Brazil. Once again, Yazoo, I would like to thank you very much, reinforce that TecTerra is a representative here in Brazil of Axospace technology and in the distribution of data generated by GRUS satellites. Thank you very much for all. Thank you very much for the RM Vale TI, for the AEB, Brazilian Spatial Agency, for this invite. Thank you very much.
Thank you, Christian.
Thank you, Christian, and Elsinore.
Thank you, Dr. John.
For the good presentation. Now we are in the presentation of João Paulo Campos from Visiona. Okay, João Paulo, please.
Okay.
10 minutes, please.
Can you see the presentation now? Okay, good. So my name is João Paulo Campos. I'm the CEO of Visiona. Visiona is a company that's a JV between Embraer and Telebrás. For those who don't know us, our focus is essentially the integration of space systems, which means the design of satellites. We also have a strong service business that we have introduced a couple of years ago, and which encompasses mostly remote sensing activities, but also other sorts of. Hold on, I'm having trouble with the internet clicker. Okay, thank you. Can you pass another one, please? Yeah. So we also have a very strong service business that we did by associating with a large. Hold on, just a minute. No, hold on. I'm trying to connect the clicker. I will let you know when you just. Can you please come back to the second slide? Okay. Another one, please. Yeah, that's it. So we provide. That's okay. That's okay. Let's move on from this one. Okay. So we provide also remote sensing service and also communication through satellite services with our partners. We have a virtual constellation of more than 30 satellites, leading companies in the sector, such as Airbus, Maxar, MDA, the Earthcast, the Hawkeye 360, and a couple of other more. Recently, we have announced also association with Capella to have a hybrid visit radar satellites in our constellation. In our satellite integration business, the most important project that we have at this point is the VCube, the 6U satellite, high performance one, which was designed first of all to validate the architecture for future larger missions, and also all the embedded software that we design in-house, thinking about the larger missions of the Brazilian space program. But this satellite also has a very high quality resolution camera and also data collection system. I'll tell you more about this on the following slides. The purpose of my presentation is not to talk only specifically on the VQ, but also to give you a grasp on what's coming on in terms of technology, what we believe is going to be the near-term future, both from the satellite manufacturing perspective as well as in the applications. Okay, specifically focus on the agriculture side. One of the things that are going to come up is that if you take a look on the recent past, there was a revolution in terms of remote sensing by introduction of the CubeSats that were providing a huge amount of data, very high revisit rates, and a very low cost in general as compared to the previous generator. These technologies, they have one drawback, which is related to the quality of the data. Okay? In general, they have lower radiometric and geometric quality as compared to the previous generation. And this is due to the technology used by the sensor, that they typically use the CCD technology, with a regular technology that we see in the cameras here. Please come back to the previous one. I'll let you know when you have to pass the slide. Okay, thanks. If you see the CCD technology, you have what they call a biofilter that is overlaying the sensor, which means that according to this architecture, each pixel senses only one of the colors of the image. So you're gonna see one pixel, the A pixel, for instance, will sense the green, the B pixel will sense the red, and the actual color that is gonna be displayed on the position of the pixel A is actually the interpolation of all the sensors, that all the quantities that were measured in the region. So it's not the actual physical measurement that is being done, is interpolation on what is in the nearby, the neighbors of the pixel. This brings some blur in the image when you compare images with the same resolution. Please move to the following. Next. What is the traditional satellite technology? They use the large ones. They tend to use one sensor for each one of the bands, and they use a technique called time delay integration, which means that all the points in the ground are being imaged by different sensors, each one responsible for each one of the bands. And not only that, each of the sensors senses the same point several times, so that you can add the energy that's captured by the sensor, as you can see in the pictures 1 and 2. Which means that the larger satellites, because of this architectural particularity, they tend to have a higher resolution than traditional CubeSats. So one of the things that we're going to see coming into the market, and the VCube is one of the first examples of this technology. Go for the next one, for instance, is that we are, with the VCube, bringing the TDI technology into the CubeSats. Next slide, please. So this is the difference. When you compare, this is a simulation, right? So on the right, that's as seen by a traditional CubeSat technology, a CCD technology, a 3-meter image. And then when you compare to a 3.5 resolution image from the VCube, you see the difference in sharpness. And actually, the differences go beyond this. One thing is that you get the true resolution when you talk 3 meters compared to the 3 meters that a large satellites provide. You're going to see less blur, more sharpness. You're going to actually be able to measure the actual level, the physical measurement of what's in the ground. So it's not an interpolation on what's going on. So that's one of the big things that are going to happen in the couple of years, specifically for application agricultural side, where you actually have to measure the actual green, the actual red, the actual near infrared, so that you can do the calculations to estimate how is the state of the crop. Please, the next one. That's another breakthrough that I think is going to come up to the market with the VCube. The VCube is probably the first satellite in the world, the CubeSat satellite in the world, that's going to bring the red edge band into the market. I agree with my previous colleague he said that was telling about the NDRE. We believe that this is a trend. All the research goes in this direction. This is a new index that is able to pick the stress in the crop with much higher sensitivity than the traditional NDVI. In the past, this technology was only available to big birds, very expensive satellites, large satellites, and the new generation of satellites are going to bring this much smaller form factor. Exospace is an example of this, and we are an example of this. We are doing this with a 6U satellite. Let's move on, please. Another revolution is going to be related to the processing. Yeah, we believe that artificial intelligence is there to stay, and we're going to see more and more applications coming on into the market as the amount of data becomes available and the techniques evolve. We believe that VCube is going to be an essential tool to train the algorithms that are, because you really need a very large set of data, and for that, having your own satellite is an advantage. We are joining forces with Embrapa and other companies and research centers to develop these algorithms. I have a couple of examples here that will go very quickly just to showcase some of the capabilities that we are talking about. Go ahead, please, next one. This is one of the results, for instance, to detect failures in the falha de plantias, gaps in the crop that translate into a low efficient use of the land. You can also see count the amount of trees that you have in a given crop and so on. Next one. The different classification of culture, that's another application that is going to increase. Next one, please. These are visionary results, okay? These are not. Next one. Plagues and growing of weeds into the crop. That's what you can see in the colors. It's where you have the weeds in the open forest, pulp and paper crop. Let's go on. Detection of fires in the woods. On the left side, you see technology that is able to detect large fires in 50 minutes. On the right, you can see a more detailed one, where you can see the front of the fire. Move on. Next one, please. Estimates of productivity. So these are examples of applications that are in various stages of development that use artificial intelligence. And we believe that with the launch of the VCube, we're going to have a jump in terms of the use of artificial intelligence for the agriculture applications because of the ability to train the algorithms easier. Let's move on to the forward one. Another breakthrough that we believe is going to be important on the next coming in is the convergence between the ability to sense what's in the crop with the ability to communicate to gather data from the crop. And the data can be in two aspects. You can have a cheap, small, low power consumption sensors that are typically going to be collected by low orbit satellites, and also the broadband real-time communications that's going to be collected through the geo satellites, which is persistent and is 100% of the time over the farm. So each one of these data has a specific applications. Ours together, all these things, and together with Embrapa, we think about algorithms to use these things and bring new innovative products to the product. These are going to be a big enabler. Next one, please. Well, all these technologies, they have to be packed and brought into the customer. Yeah. So for that, we are designing a platform that's actually able to gather data from the medium resolution but high revisit rate satellites, such as the Sentinel, the Landsat, the Cebers. The satellites, if you get all of them, you can images, I would say, about every 3 days or something like this, yeah, in various characteristics, but typically very high quality image. And but we're going to integrate that with our own constellation and our partners' constellation. So we're going to integrate this with the VCube, and we already have these platform integrated with the Maxar and Airbus satellites, so that we have from the very, very, very high resolution to the high resolution, low resolution. The whole thing you have will provide you high quality imagery with high revisit or high resolutions when in the spots where you need it. Also, by fusing the data from the IoT sensors that I showed in the previous slide, and also the capability to analyze these data with algorithms. Because at the end, we believe that the end user is not interested in the imagery itself or the communications. The satellite is essentially poised to provide, it's a decision-making tool, okay? So you need to be able to, as opposed to give them the data, give them the answers. And that's what the platform provides. Please, the next one. So essentially, we have a platform in the internet where you can, for instance, register your property and so on. This platform will gather data from the various satellites that I showed you. It can be high revisit data or high resolution data as required by the situation. The platform will fuse the data and analyze the data with the algorithms that I showed you in the previous slides too. Automatize the process so that everything flows into the producing chain of the user. Distribute the information that is required for the decision making. Next one. A few other examples. Next one, please. Please, next slide. Okay, you can pass. So, I mean, the indexes are there. Can move on. Various indexes are already being used, NDRE, the moisture of the crop, and the amount of nitrogen into the crop. Everything is reality now. This is not I will not say that's the future, right? This technology is ready to be used, right? So we believe that. Please go to the next one. You can pass through this one. Jump to the last one. This seems scientific, science fiction, but it's actual reality. Okay, what we believe we are heading to is the integration of that various technologies. But the most difficult part at the end is going to be to put together a service where we can provide this device with the proper sale channels, with the technical device at the end, with people that are trained to use this data and provide to the farmer the actual device, and not to say just the next another. Please. Given that we are talking about drones and autonomous vehicles, why not to think about autonomous airplanes or autonomous drones actually taking this information and actually making an intervention in the crop by delivering the right fertilizers or venoms and so on into the end. Everything integrated as a seamless service. So this is where I think that the technology is heading to. The building blocks are there. They can serve to spin-off in different applications. Here we focus on the farmer, but we can think about the banks, the trading companies, and so on. So we believe that as the cost of the data and the technology, the cost of the data goes down, the technology improves. I believe that we're going to see more and more the satellites taking part of the daily life of our farmers as a big productivity improvement tool. So thank you.
Thank you very much, João Paulo. It's very good presentation and very clear for us. Now, let me pass to Leonardo Antolini, the Kinetic Kleffman Group. Please, Leonardo, you may start.
Okay, thanks for the invite. Thanks to everyone who's presenting. I believe that the technologies you are showing can help the farmer with this interpretation of what is happening in the fields. And well, may I share the presentation, or you're going to share by yourself? All right. So for those who doesn't know, Kleffman Group is now part of Kinetic. So we are the leading company in market research in agribusiness. So I am the Pharma Panel researcher and research director here. And in this presentation, I will show you the profile of the farmer and how the technology is already in the field. Of course, what we were seeing here is the edge of the technology. I believe that there are some things a little bit simpler in the market which is already working. And this question is about the technology and who is going to implement that package that we are talking about today. Let me try with my passer here. Yeah, it's working. So I have 4 topics about the newest generation in the field, who is the farmer and the adoption of technology. And I also did an analysis here for this event specifically that shows you who are the farmers in the front of the technology. You're gonna see that they are in the front, of course, but there's a lot of space to adopt, especially imaging by drones, by satellites, by planes, and so on. And also we have this projection for the next 5 years. What I'm about to show you is based on the answer of the farmers. This is the newest research we did on digital farming and precision agriculture. It is about 3,000 farmers that we interviewed, and it represents like 63 million hectares of grains. So soybeans, maize, corn, and so on. And it represents also 77,000 farms. So it's a lot. It's a very quantitative study, and I hope you like it. Okay, so the new generation is changing the figures in the field. If you look on the bottom, you see the age of these farmers and how many farms are in their hands. So you see in Brazil 72,000 farms more or less, and you have the age distribution. So if you look at Cerrado's region, Mato Grosso, Goiás, Mapitobá, and so on, you see that the farmer there is already younger. It is traditionally younger than the rest of the region, especially in the south. But what we discovered in this research is that the south population is already young enough, you know, because if you look from above, you see that, okay, this farmer is more traditional. He's never going to use NDVI. He's never going to use biomass maps and so on. And what we discover is that this population of farmers with 30, 40, even 50 years is able to manage these things because the things are becoming simpler, I guess. And you work with technology, you know this, that age is related to adoption of technology. So this is a positive news for you guys, because the market is becoming more, I think it will have more acceptance to these technologies we are talking about, right? So you see the market who is already more mature for these technologies, it is the Cerrados. You're gonna see on the previous, on the next slides. What we did in this study, we segment the market between a non-user of technology, a light, a medium, and a heavy user. If you look, this is the set of precision farming and digital farming technologies used in the farms, and you can see we gave a score for each one of these guys, because it's a lot of tools, and if a farmer is not adopting anything, he will take 0, right? But if he's adopting, for example, variable rate of fertilizers and imaging by satellites, for example, he would take a note, which means with the higher the note, the higher the level of technology adoption, right? So we split the market like this. A non-user of anything, it doesn't do soil analysis, nothing. He's a 0, so he's a non-user. A light user is between 1 and 9 points, medium 10 and 19, and heavy users between 20 and 83. So I will use only the names of these segments right now, and you can see what can happen with age. So of course there is a lot of non-users in Brazil, very big markets to explore, right? But if you see on below, if you look at the younger the farmer, the higher the adoption. This is true also in this segment. Then you can see these guys on the 30 years, on the 40 years, they are the main consumers which exist now. So of course these guys can understand what we were saying in this presentation. Of course, NDVI, he maybe already uses something, and he can choose their package based on these technologies. But the problem is that the market of, at least for these crops, it is heterogeneous. It's so different. You have situations that you have a farmer in the front of the technology and others without adopting anything. So why are you using these maps? Of course, it gives you the recommendation of the same inputs that you have or not have or must not do. And if you don't have, for example, a variable rate fertilizer machinery or a variable rate seed machinery, it means that they will not be able to use it. So what I see in the market is that there's a lot of solutions, and we need to link these solutions, a lot of technology being developed, with the use of the farmer, because otherwise these farmers, they are very skeptical about every technology that you are going to present. So they need to test, they need to see, and if it is proven, they're gonna like it, they're gonna adopt. Another thing that it is interesting, it is about the regions also. So you see, there are some differences between the regions. Of course, in the Cerrados and some regions of Sudeste, Southeast, there's a lot, there's more heavy users, but the non-market is the bigger market, right? The light users or the non-users, they are there waiting for someone who will make their lives easier, and the adoptions of variable rates and productivity maps and these things are very low. Okay, so how are we going to explain these things we were showing and the industry developed to the farmer in a very simple way? Because it is all about this, right? So this is a challenge. Of course, there is technology, and the companies should look at it to help the farmers to adopt their technologies, for sure. And I'm going to the next one. And I got this persona, which are the heavy users of technology in Cerrado region. These guys are in the pinnacle of technology, right? And you see that there will be some things that they even then they don't adopt, right? So looking at this segment of the market, they represent more or less 4.5 million hectares, right? It's not a lot because we're talking about almost 60 million hectares of these crops. And you can see on the left the size of the farm. So they are concentrated in big farms above 2,000 hectares. Of course, this can be more or less for soybeans or for winter crop or whatever. But the size of the farm, the size of the market per each farmer of these are related to this size, right? And of course, you can see on the center, the average of age of these guys are 40 years, 30 years. So it is a young guy with a big farm. So they represent more or less 1.5 thousand farms, which is not a lot. Very, very niche market yet. And of course, they use precision ag or digital farm. It's been a while already. So they have more or less 2 or 5 years using precision farming, but you can see that is not a lot. A farmer does like 40, 45 maybe crops in his life. So he's doing 5 with precision farming. So they don't have experience, so much experience on it, right? So it is a very new thing, even for these guys. And another thing is regarding the technology, the package, which is there. I circulated with the red square there, the imaging. So you see on planes, you have 90% of adoption in the number of the farms. On drones, 35, and satellites, 32. Percentage of adoption within this segment. So of course it's not the majority of the market. It represents only 4.5 million hectares, 1,500 farms. But you see, even within this segment, which is the frontier of technology in the field, you have space for adoption of satellites. Of course, what drives the adoption of these technologies, especially the aerospatial, are the navigation and the variable rate. If the farmer already has a plant or a fertilizer machine with a variable rate, and he might be able to use a biomass map and NZVI recommendation together with all the recommendation that he must do also in the soil, because the satellite per itself, it doesn't solve the problem by itself. So it needs another tool, another interpretation, right? And so this is the frontier. Within the frontier, you see a lot of space for growth in this segment. So this we started in the early majority stage of the market. So we transpassed the pioneers, we transpassed the innovators, and now the market is going up. This is the main conclusion of this study. Regarding this is another qualitative variable we put in the study regarding the advantages of using precision farming. You see in the middle, you see that they have advantages. They see things, and it is profitable. On one point we ask also is regarding the information security, because there is a lot of data going through the machinery, going through the satellites, and they don't seem to be very worried about it. But I guess the companies must take care and take this with responsibility, because if you know the farm during 10 years, 50 historical images of satellites, I know you can have this. So it will be the blueprint of the farm. So you need to take care on this. What is for the next years, right? This is regarding the next 5 years. We ask the intentions of adoption of a technology, not regarding satellites or these things, but you can see that the CAGR is these two numbers for the next 5 years. So you see that, for example, in 2020, the area adopting any technology of precision farming or digital farming, it is 8.6 million hectares, more or less, okay? In the next 5 years, this will grow to 11 until 12 million hectares. But if you consider the total arable lands in Brazil, this is nothing, right? You have a lot of space to grow. And what makes the farmer adopt something is that they need to know what is this about. They need to know how it works. And this I put in the recommendations for the industry and the sectors, which is here. So, of course, the market is different. If you go to this farm in Lucas do Rio Verde or in Sorriso, in Mato Grosso, you're gonna find this farm that I've showed you here. But if you go to a very traditional region, a very small farm, with a farmer which he doesn't have access to information, you're not gonna find it. So I think the sector as a whole may teach the farmers and train these guys with the benefits of the solutions. Of course, there is a lot of engineering here, a lot of technology, and this must be aligned with the marketing and the real needs of the farmer. Because if you think about how things were done in the past regarding crop protection, seeds, and even machinery, you see that you can improve a lot of things for these new technologies. And the good news is that they are already using something, and this is growing. So, of course, you have to look in Brazil and split at least by 2, in South and Cerrado, or even within the states, within a specific crop, there will be differences. So you have to look on the market to see what are you capable of, and to access these farmers. This is another challenge because Brazil is huge, right? So you need to have distribution channels or sell online. The farmers already is on the platforms, so I think this is a nice opportunity for those who are in this moment now. The timing is good for those who are entering this market and develop solutions for these farmers. And well, if you need more information, please contact the email of my colleague. It's milor.mondini@kinetic.com. And of course, we can speak about this project or other projects. And thank you very much for the opportunity. And this is it. Thanks.
As you can see, we have a very huge opportunity for satellite image processing applied to agriculture, for different analysis and diagnosis. Since we have only 5 minutes to conclude this session, I would like to hear from you, how can we have online information enough to provide some diagnosis, management, orientation for the farmer producers, based on this images, hyperspectral and visual information from satellite images. For example, how to manage irrigation or pesticide spraying in the field. Feel free to answer. Did you understand my question?
Actually no, João.
When we have all this spectrum of information, about the plant, the trees, the soil, or soil moisture availability in the soil. How can you think this information will be provided to information system to have some diagnosis, management diagnosis?
Yes, well, I think that in my perspective, the technology is mature and it's ready to be provided. I think that as I showed you, of course, tried to show a bit of what we have now, but also given that there is a technology forum, I wanted to give a grasp of what's going to happen in the next couple of years. But I think that the main challenge is not related to technology per se. It's related to how to access the farmer, how to provide them with the technical support so that they can use the technology safely and they can understand the data exploited. I think that's where the challenge lies. The technology per se is I mean, it's mature. It's to a large extent. We have already a couple of customers that are using that, mostly in forestry, but if you more sophisticated customers, they have already access to this. Yeah. The thing is how to expand to a larger base.
Yeah, may I compliment? I totally agree with you, and I totally agree because I've been working with some of these companies also, and the challenge is this one: technical support. Because maybe you have a cloud, and what do? Maybe you are in the infrared spectrum, all right, but I don't know if all the technologies are working with this. And you have to have this technical support because all the others manufacturers of tractors, of seeds, of crop protection, they have. So if they are used to already, so they need to have this relation, right? I think it's more. My opinion is more or less like yours.
Thank you very much. If you did. Mr. Yasunori or Mr. Christian have some final remarks. We have only 1 minute.
Sure. From a Japanese perspective, I think I agree with both of the two colleagues that mentioned the technology is there. I think from a Japanese perspective, the cost is quite high here in Japan. So the farmers or the beneficiaries of the data are ready to use and they are quite savvy with technology, but they need to justify the cost. So as an operator of the satellite, we're working very, very hard to find a way to reduce the cost so that the farmers can truly use for their benefit.
Okay,
thank you.
Christian, your final remarks? You have only 1 minute, please.
Okay. I believe that all technologies present here today will be complementary and convergent, and it will be very important for the development of agribusiness in Brazil, in Japan too. Especially in the time of coronavirus time, that direct contact is restricted. We will need the remote sensing associated with artificial intelligence for constant territorial management and agricultural production. So that's it. Thank you very much.
Thank you very much. Thank you for everyone who's listening to this session. We're very pleased to have all this technology available to agriculture. I hope very soon we'll have this work in the field and in partnership with Embrapa, I guess. Thank you very much.
All right, guys. Thank you.
Thank you very much. Thank you.
Thank
Thank
you
you, Yazoo.
so much.
Very good.
Thank you. Thanks, guys. Arigato.
Thank you.
Continua. Né?
Arigato.
A programação do quarto Fórum continua. Daqui a pouquinho,
Obrigado.
às 2 horas, nós vamos ter um segundo painel sobre financiamento do setor espacial. E eu aguardo você, então, às 2 da tarde para o nosso próximo painel do Fórum da Indústria Espacial Brasileira. Até já.
O Grupo Energy Telecom, através de suas 4 empresas, atua em todo o Brasil, integrando os principais serviços e soluções quando pensamos em tecnologia. Projetos de Public Cloud, comunicação unificada, Big Data, infraestrutura, Data Center, Client License, Cybersecurity e educação. Você pode contar com o Grupo Energy Telecom. Sempre a melhor solução.
Nós protegemos a tecnologia para você explorar novas realidades. Fazer o que quiser, quando quiser. Fazer amigos virtuais. Estar perto, mesmo estando longe. E conquistar novas fronteiras. Garantimos sua segurança digital para um futuro melhor. Kaspersky. Bring on the future.
Vale do Paraíba, uma região única com múltiplas vocações. A nossa é a tecnologia, é a inovação. Nós somos a NIP-BR. Trabalhamos para integrar, conectar, expandir, informar, entreter. A NIP-BR é solução corporativa, é internet, TV por assinatura, é telefonia digital. Os melhores serviços com o melhor custo-benefício. NIP-BR, sua melhor opção em internet, telefonia e TV por assinatura.
Você é daqueles que acham que ser moderno é ter um aplicativo para cuidar do seu dinheiro? É também. Agora, moderno mesmo é fazer parte de um grupo de pessoas que cooperam e crescem juntas.
Tem gente que acha que um bom atendimento é ter um gerente pronto para te ajudar. Nada mal, né? Mas pra gente ter voz e participar das decisões relacionadas ao nosso dinheiro.
Tem gente que acha que somos um banco. Somos muito mais. Somos feitos de valores.
Our infrastructure and natural resources can't keep up with growing demands. We need to be smarter. We need to care more. It's time to create smart infrastructure. We can because we connect energy systems, buildings, and industries to adapt and evolve the way we live and work for the good of the planet and the people. Creating environments that care. Smart infrastructure from Siemens.
A maior rede de pesquisas do mundo, com 5,5 bilhões de acessos por dia. Uma rede social avaliada em 70,7 milhões. Sabe qual a semelhança entre essas empresas? O investimento em softwares e algoritmos inteligentes. Tinova e SPS.
Na era da transformação digital, a Tria Software é o seu parceiro ideal. Trabalhamos com a aplicação de solução em software padronizada ou sob medida para melhorar o desempenho dos processos de sua empresa. Tria Software.